our talk today, making the SQL query processor work for you. I am Kate. I'm here with my coworker, Derek, and our other coworker, Kendall, is he's on the slides because he presented this exact same talk at Live 360 this morning in Orlando. And all three of us together are the PM team for intelligent query processing, and you can reach us at this email that we have on the slides. So a little bit about us. I have worked in SQL Server for 13 years. I've been a tester, a dev, now I'm a PM, so I've seen a lot of different angles for the same problems year after year. Kendall, I said he's not here today, but he comes from the field. He brings a depth of experience in perf tuning and the customer perspective, and Derek can introduce himself. You want me to introduce you? But Derek, he's so friendly. What do you want me to say? I don't want to read this. No, he says he's just here so he won't get fined. But he's a great guy to work with. We have a lot of fun together, the three of us, which hopefully will come through as we give this talk. So our talk today has hopefully a little bit of a story. We've got three main players in the story. We've got Hugh Query. He's a DBA for an HTAP system. He's all about that. He has a little bit of control over his code, and his main challenges in query processing and performance center around large-sized tables. We got another person, Sharon Point. She's a DBA for a system or multiple systems that run commercial off-the-shelf software. Right? She can't change code. She can't change what the queries are that are going to the system, but she's still responsible for doing performance tuning. Right? So think query store, stuff like that. And then there's this other person in the story, and his name is Fab Rick. You may have heard words like that this week. And he's just like a developer. He doesn't want to think about databases. It's not really his thing. He just wants to write a fantasy football app for him and his friends, and that's all he wants to do. So at the beginning of our story, we've got Sharon and Hugh are working together, and they want to upgrade their system from SQL 2016 to SQL 2022. So the first thing they do is they bring the data over. They just restore it in 2022. They don't change any other settings. They leave it all alone, and they run their workload against it, right? And so these numbers aren't helpful as is, but we'll do some comparisons. So they do this. They restore this back up. They run it. They're in compatibility level 130. These are the numbers they get. They run it again. They decide, okay, let's see what Compat 160 has to offer. They upgrade their compatibility level of the database to 160, and they run again. Okay. Now let's do a side-to-side comparison of 130 to 160. Same workload, no data change. All they did was upgrade the compatibility level, and the performance really improved. Right? You can just see that the resource consumption reports in Query Store, you see that you're getting higher throughput. The whole workload is taking less time to run. So this looks like a win. So we can actually see the concrete numbers here. We've got the total, in terms of total duration, CPU time, et cetera. It's just so much. I mean, logical and physical reads didn't change, which would make sense, because you're still reading the same data. You still have the same queries. But you are seeing that wait time, CPU time, et cetera, have decreased. So here's another look at these numbers based on averages and totals. And you can just see that 160 is really looking like a winner for this upgrade story. This database, by the way, happens to look a lot like TPCH, but with some data skew, just to give some perspective on what we tested here. All right, so why does compatibility, oh, I guess I'm still talking here, never mind. Why does Compat 160 perform better? So we've heard about some of these feedback features. Sharon and Hugh have heard about them. They came to pass last year. We have several features called C feedback, memory grant feedback, degree of parallelism feedback. We'll talk about them in detail more in the talk. But let's just say they did a little digging. They found this query to look at this planned feedback table. And they can see that these features are kicking in. So CE feedback has 3 examples here where they had at least 9 plans where CE feedback tried but said we don't have a recommendation. One where we tried a recommendation, decided that actually it was better without that recommendation, and then 4 queries where CE feedback actually kicked in and made an improvement. Memory grant feedback had 303 different queries or plans that it felt that it could provide a valuable recommendation for, which is pretty cool. And so you can even actually query specifically what those were. So this query here actually shows you that these are the different feedback features. This is what they did. This is the changes that they made in your system to improve. So this is pretty cool. So in Compatibility 160, the engine adapted to that workload in a way that it couldn't in Compat 130. So why did it do that? How did it do that? Now, before we answer that question, I'm going to talk real quick about how query processing works, so we have a sort of a shared understanding at a very high level that we can use as a foundation for some of the concepts we're going to introduce. So query processing, what is it? You send a query into the system, magic happens, and you get results, right? What is that magic? That's what we call query processing. The sort of internally, we bucketize it into query optimization, right? That gets you your query plan, and query execution, that takes that plan and turns it into results. So let's look at query optimization. You get your query in. We do a number of things. We look at the statistics or the histograms on data. We read those in using cardinality estimation. We make some interpretations of that data, and we come up with like estimates of how big sub-results are going to be, subtrees, some parts of the query. While we're doing that, we're exploring the plan. We're rearranging operations in a way that's semantically equivalent to get the most efficient thing. And we decide what's most efficient by looking at costing, which basically we say, okay, this is the cheapest cost plan. Let's pick it. We get a query plan. And this is the one that we think is best, right? We don't know because we haven't run the query yet. And that's critical. That's where that feedback part comes in. Was what we think is best based on our costing, our algorithms, our heuristics, right? Now, in query execution, we just take that compiled plan, and that's like a vision, right? I want to go from here to Redmond, right? But it's not really the executable plan. The executable plan is more like a map, right? And a bus schedule and a bus pass that says this is exactly how you do it. So it takes that compiled plan and it turns that into that executable thing. You can follow it step by step and executes the plan, and it makes calls down to the storage engine as appropriate to get rows, to get pages back that it can filter through and decide what to return. So I just wanted to kind of give that baseline, and then we're going to go ahead and we're going to introduce and talk about what compatibility level is. Because remember, all Sharon and Hugh did when they did that upgrade story was they just changed the compatibility level. So we wanted to talk in a little bit more detail about what that is and what it means.
Yep.
So,
Awesome. Thank you, Kate.
Yeah.
So we won't completely demystify compat levels, but we'll talk a little bit about them. Just quick history lesson. Database compat levels, can't even talk this evening, were really introduced early on SQL Server 2000-ish, 2005, to help gate features, right? So we would introduce a compat in SQL 2000, 2005 would come along, and we would start deprecating features. 2008 came along, we'd start deprecating older features. 2008 R2, which no one likes to talk about, except me. SQL Server 22 came along, and we continued that pattern until we got into SQL Server 2016. At 2016, the team decided, you know, it doesn't make sense to just start deprecating features. What we're going to do is maintain a base level, compat level 120. We won't deprecate anything lower than 120. We'll always let you use 120. But we'll start adding new features to the higher compatibilities. So we went to 2007, 2019, to 2022, and 2022. And with each level that we added new features. We changed some behavior, but we tried to minimize the changes that occurred with the DB Compat changes.
Derek?
Yes.
One question. Do we gate all features behind compatibility level?
We do not.
Just plan affecting ones, right?
Just plan affecting ones.
For the most part. It's sort of the general guideline we try to use.
Well, typically it's plan affecting changes or language semantic changes.
Yeah.
A good example would be when we introduced the windowing function, awesome function. I have the pleasure of having to PM that function. We had to gate that behind compat level because we were seeing that folks were using, I don't know, the term window in columns, or they call the table window. So we couldn't just upgrade to 2022 and all of a sudden you refer to the window function and now things get kind of confused. So sometimes if we change the semantics of an operator, this is not true, this is just an example. So daytime 2, as an example, when we introduced that, that data type was more precise. We couldn't just throw that out there and say, hey, just use this. We had to be purposeful with it, and we protected that behind the DB compat. But yes, typically it's a plan affecting change. Thought I saw your hand. One thing to note is, what I did skip over in this previous slide, is Azure SQL Database and SQL MI are currently at database compat 150 and not 160. So sometimes people ask questions, well, how is SQL Server 22 at the latest compat? And MI and SQL DB are not. The engine between SQL Server and SQL DB MI is the same, so the functionality is there. It just takes us a little longer at times to make that compat level change in Azure. And when we make the change in Azure, we do not change your existing databases. If you create a new database, it will inherit that compat level. All right, talked about that one. All right, so one thing we always try to ensure is predictable query performance. All right, so the magic that Kate just finished talking about, we will sometimes unintentionally cause what would seem as like a query regression. If anyone was around when we introduced SQL Server 2014, that was one of the times when we made a major change, really, to the cardinality estimator, because we had to try to make things better. The legacy CE was great. It had its time. It was around from SQL 6.5 to 7, and it started to kind of show a little bit of age. So we had to modernize it a little bit. In doing so, caused some performance regressions for certain types of workloads, and I'll talk about some of those in a little bit.
I mean, so Derek,
Yes.
that was one of my projects when I
know.
first joined. So you guys can blame me, and you can talk to me. We can talk more if you really have problems. Anyway.
Yeah, the 2014 change was hard on quite a few folks because we did make some changes that people did not expect, right? And at the time, what I didn't put in my intro slide was I was in support at the time, so I got to talk to a lot of you folks, go on site with a lot of you folks. My colleague in the back, Arvin, was around at that time, and we did a lot of support. So thank you, Kate. That was
thank
wonderful.
you for your.
But all the things that happened then are fixed, are better now, smoother now that we went right from compat like 14 to 16. That we're not going to feel that jolt.
If you're on compat 140, right, you have.
Yeah,
so if you're using the legacy, that CE difference was just a big step that we took. For the most part, we don't have features other than that are real got-yas in terms of that upgrade compatibility.
We already got through that 14
Yeah.
thing and
Yes.
changed a few things, and it finally smoothed out. And now we're moving from like 2017 to 22. You don't expect a big jolt in the road again.
We don't have any red flags for you right now. No.
No. There's everything we're adding now is goodness. We're not making major changes to the CE or the optimizer, right, which would be another really major change. So if we decide to touch that, then you want to be a little more careful with your. We want to do a lot of testing. We don't intend to harm anything, but there's a lot of different workloads out there, and we can't account for everything during our testing. Yes.
So,
Yes does not mean we fixed everything. Yes means we're still adding, don't do this, don't do this.
Okay.
it was inline UDFs, in case the people didn't hear the question.
Yes, the question was about, did we finally tackle and fix inline UDFs, which is a pain point for a lot of folks that use that functionality. As we find issues, sometimes changing those things breaks other things, right? So then we just add to the list, say, well, don't do this. Right. We are trying to figure out a way to smooth that over, so we fix all of those problems without breaking existing functionality.
No, it's a very good thing to do. I mean, EDF needs attention, I agree.
Yeah.
But
We're getting there.
certain things that we need to know,
Yeah.
I agree.
not necessarily correctly.
Understood. So one other quick thing on compat levels, like I mentioned, when we did make that big change to the CE model, something that broke a lot of folks, and I won't get too deep into this, I will probably hand off to Kate for this, because this is her specialty. She loves this
boy.
stuff. There's the concept that we call independence and correlation, right? So basically the cardinality estimator will make an assumption that when it sees data, it used to say all this data is independent, right? So this value has nothing to do with this other value. We changed that behavior, and we tried to say, well, if you have boxes and someone has, I don't know, a table with stores, they're probably correlated. That broke a lot of applications with us making that assumption. The other big change at that time was, I think I mentioned date time 2, where we tried to make things better. We made the precision more precise. However, in doing so, we would do an implicit conversion. So if you had you had a date time 2 function, we try to implicitly convert for you, make things nice and more precise. But that caused issues with a lot of applications that couldn't deal with the preciseness. And the way around that was you had to explicitly cast it, which caused other issues. So I think that we're done with those types of shocking changes, but can't guarantee.
We don't have any current ones planned.
Yes, very good.
That's all I can say.
One thing that I totally glanced over, and this is one of my favorite things. In 2016, one thing that we did add that was great for everyone should use is Query Store. Now, granted, those that did go through the trouble of turning on Query Store in 2016, it wasn't perfect, but Query Store was one of the best things that I think we've added to the engine, right? So we like to call it our data flight recorder, right? So it records mostly everything that goes on in your system, and it really helps troubleshooting tremendously. It's only gotten better. 2022, it's so good, we've turned it on by default in 2022. You can turn it off, but I would recommend that you keep it on. All right, so let's talk about the intelligent query processing family. So in the QP space, query processing space, we have, I don't even know the number, 40, 50 different features.
Well, they're all on the next slide. But
they're all on the next slide.
A lot of them.
We have a lot of features. So a lot of times, one feature didn't really correlate to the other feature, and it was hard for folks to understand what we were doing. So we came up with this concept. It used to be called adaptive query processing, but we changed the name to intelligent query processing to try to convey that we're trying to make the query processor better with all these little independent features. And during that journey, we tried to take each independent feature. So starting in SQL Server 2017, we tried this concept. We introduced interleave execution, batch mode, and for, this is a little misleading here, but we did batch mode for memory grant feedback in 2017. We extended that in 2019, the light gray, to include I can't even talk this evening. Table variable deferred compilation, batch mode row store, which was a big enhancement. We had approximate count distinct, row mode under memory grant feedback, We did scalar UZF inlining, which still has a few problems. And then in SQL Server 22, we added even more to the family, CE feedback, DOP feedback. We'll talk a little bit about some of these features, but we really won't go that deep into them. Any of the features that you see that have an asterisk on them are in SQL Server 2022. They
But not,
are
not in Azure yet.
not in
They're
Azure
coming.
yet.
They're coming to Azure.
Correct. The exception up here would be the DOP feedback. It's in private preview.
Limited public, private preview, something like that.
It's kind of right in the line there.
Yeah.
We got a query store hints. And we adopted a feature family that was introduced in 2017 that we call automatic tuning. And with that was a feature known as automatic plan correction, which is an awesome feature. It tries to detect cases where you have, say, bad parameter sniffing, right? Or a plan that regressed in behavior. We'll detect that, find the last good plan that ran great, and we'll essentially force that plan. We made some enhancements to that in 2022. We also added index maintenance, which is only Azure today. Our team is working on that feature currently to try to make index maintenance, the goal is to try to make index maintenance a thing of the past, right? So people run defrag, reorg jobs, and we're trying to make that experience easier and better. It's coming. It's not here yet. All right, so the other thing that we have on this slide is we added the numbers for the DB Compat where those features actually got lit. Not all the features were protected behind database Compat. It's a little small, so it's hard to actually see the numbers. I'll give you a chance to take a picture. And also, some of these features rely on Query Store. And they rely on the Query Store because that's how we get the feedback. You execute a query, we capture it in the Query Store, we see the query again, and we can do comparisons.
Question, if, somebody sends off query store to read-only or something for whatever reason, or turns off itself, does all that good feedback stuff stop?
When you're in read mode, only yes.
Well, it depends. I mean, if you have feedback that you've already learned and it's in Query Store, it will continue to be used because you can read from Query Store. But the new learning would not be persisted, right? I mean, actually, DOP feedback, I think it has like 2 levels. Well, it will try to keep it in memory. And so you might lose anything that didn't get persisted on a restart or a failover.
Awesome.
Yeah.
Kate, you want to talk about some of the
Oh, it
There's
is
a
my
couple
turn.
of
Oh, yeah.
features, yeah.
All right. We're going to talk about some more features and how they're working. Great. So, yeah. No, please.
I also saw yesterday in one of the slide demos that somebody else was doing, they went and like cleared Query Store.
Yes.
Yeah.
Which is a statement that I probably wouldn't ever want to use. But if that happens, then what happens to all that feedback that would have been in Query Store?
It's gone.
If you-
like the next stuff.
It's gone.
If you clear the Query Store, we have to start our learning all over, right? Because we store it in. Yeah, go ahead.
So let's say I consider query store as a database driven object. So say my backup query store got captured those same learning and I restore somewhere
Mhm.
and try to mimic those things.
Oh, I see. Like you're saying, if you take a capture of the Query Store and try to like restore it with the database that it learned from, or yeah. Yes, it should
Yeah.
should still apply. Yeah.
So
Yeah.
even my query store recycle is like 500 MB, but I have, let's say I know that this is my learning point somewhere.
Yep.
I can take my backup to store it somewhere else and try to figure out.
Yes, and
yes.
it's actually, it's a lot of folks use that technique when they're thinking about upgrading to another version of SQL. So they'll back up their query store or their database, take that database, put it on a SQL server at a different level, and just start doing data comparisons, right? Because you have the query plans in there already from what executed before, execute some basically your same workload again, and you can apologize.
Compare.
You can compare the differences between before and after.
One more question, I'm sorry about the query store. If I have a
Parameter sensitive plan.
Parameter sensitive plan. Oh, parameter sniffing.
yeah, so how accurately I can find that it's parameter sniffing or?
In the query store, it's a little harder to find parameter sniffing because a lot of that data that's in the query store, you'll see the estimated plans, right? You won't get the actual plans.
No, then
Yeah.
I read my query store correctly. I just want to make
Yes.
Yeah. Yeah.
I'm not missing some of the stuff.
Okay, so we've talked a lot about these features, and I'm not going to give demos of them today. We talked about them last year at PASS. If you go search for data exposed and my name on the internet, you can find all sorts of demos, talks, other presentations to talk about these features. But we wanted to talk about them briefly, not in depth, so that you guys have some background. So memory grant feedback, right? It's going to look at the amount of memory that a query is using and adjust that memory consumption either up or down to prevent a spill or to allow for more throughput, right? Cardinality estimation feedback, like Derek was saying, it will tweak. We've got a couple of dimensions on which we can tweak the assumptions we make when we're interpreting those histograms or interpreting joins, for example, and how we estimate the number of rows coming out. Degree of parallelism feedback will take a query with a lot of parallelism and sort of gently or slowly step it down until we reach a sort of point of maximum parallel efficiency. Yeah?
Does that feedback take account query hint that says to use a different level of parallelism or to use the old cardinality?
So right now, I think a lot of these features, as they're currently implemented, if you have a query hint that you've hard-coded, we will say the user knows what they're doing, and we will not engage the feedback mechanism. We're looking at ways to work around that because some of our features actually add hints, and so we need to be compatible with hints. That's something we need to do. That's not how it's currently. Now, each of these features, feedback, right, implies that we're looking at repeated queries. You can't provide feedback or use feedback from something that ran just once, right, in an ad hoc way. So really, we're only looking at repeated queries. And not every workload is going to benefit from all three features, right? Some systems, like that, way back at the beginning, that example I showed, that upgrade example, Sharon didn't see any examples of DOP feedback kicking in because none of her queries took more than 10 seconds. DOP feedback has a requirement that it must be a longer running query for it to consider it for feedback. So that's just something to keep in mind. And as I said, there's lots of demos out there about these. If you search for my name and the feature name, you'll find some information. So what I want to talk about today, one of the features is query store and secondary replicas, right? So right now, you've got a system, you send queries into your database, that sends information into the query store, and you can learn stuff about how things are running, right? But in reality, that database and that query store, the query store just lives in system tables inside the database, right? It's not its own special thing. So if you have a situation where you add secondary replicas, and I'm sorry they're really faint here, I don't know why that happened, but those secondary replicas are read-only. So you send queries to them, but there's nowhere they can write, right? You can't write query store information about your plans, your runtimes, your exec stats. If anything running on the secondaries, you're running blind. You can't get that deeper insight. So introduce this feature, query store on secondary replicas. And they ended up even fainter here. I'm so sorry. Just assume that those arrows point to pictures of databases. Where the queries go to your secondaries, and then the secondaries actually send the information about what's running back to the primary. The primary writes it in the query store in a way that sort of disambiguates this ran on the primary or the secondary, right, based on the role. And then that all goes into the query store, and then you can learn about what's happening on your system, not just on your primary, but also on your secondary replica. This is actually a SQL 2022 feature that we haven't released yet. I know that sounds really confusing. It's going to come out in a CU. I don't know when, but it will. Any estimate? Yeah, go ahead. Sorry.
Like, do you have like a special field for the insurer? Because the insurer for the primary and
So you can't write to a secondary replica, right?
I understand that, but there should be some kind of how I can distinguish the primary replica from the secondary.
You'll see a demo in a minute, and I think that will make it clear. Yeah, I can't give you a. That'd be probably not realistically. I know, I'm sorry. I'm hoping in the next year. Yeah, question?
Maybe my question sounds stupid, but when we gonna be actual mode and we switch replica from read write to read only,
Yeah.
where my primary becomes secondary, secondary becomes primary,
When you fail over?
and how the query store gonna be know that now I need to imply all this my query store in this server, not
So it knows. So query store and secondary replicas knows how to move with the primary in terms of, so it would pick back up. And actually, I'm going to show an example. I don't have a failover example, but I'm going to actually apply a query store hint on a replica, and it will be on the replica type. So it'll be run this query with this hint on the secondary. So when it fails over, the new secondary would pick up that same hint. That makes sense? Yeah, go ahead. Yes. Yes, it is. It is. It's going to go everywhere as soon as we can get it done. Yeah. This should work for distributed availability groups too. Yeah. The query store fails over when the database fails over. Yeah, it's already copied, right? Because it's log shipped it to the secondary, and so when the old secondary comes online as the new primary, it already has all that information. It can just now write. And so in order for this demo to make sense, I'm going to do a quick refresher of something called query store hints. Sharon loves query store hints because she can't change code. She can't hint things in the code. What that does is it basically allows you execute a query. Once the query is in query store, it has to be in query store, you can actually create a query store hint. There's some syntax here. You don't need to memorize it. It's all in our documentation. But then once that query store hint is in the system, you can actually see it there. And then the next time the query executes, it's going to pick up that hint and use it. So Sharon, she did this upgrade to SQL 2022 of her database. She got some learnings from CE feedback, et cetera, but now she wants to scale out. She wants to leverage secondary replicas, and she wants to actually push it to Azure. Let's just do it all at once, right? She can't change the code, so she's going to use the query store to change the behavior. She had some learnings from CE feedback, and she's just going to take those learnings. You can find them by querying the query store what the hints were, and because CE feedback actually just applies hints through the mechanism of query store hints. And she'll take those hints and she'll just apply them manually instead of waiting for the learning to happen. And she's going to do this not just for her primary replica, but also on her secondary replica. So I've got a demo here, and I got to give it a start here. Boom, boom, boom. Are we good? Didn't like my click. Oh, there we go. Oh no, we don't want that audio. How do we make the audio stop? What? Fix it, Derek. Oh.
If it will click. It's not taking the click.
I know, it doesn't like me. All right. So all I said was primary connection is the green bar, secondary connection is the cyan bar. We're checking the query store state on the primary, and you can see it was read-write. We're going to execute that same query on the secondary, and you can see that we've got this other status, which we say is read capture secondary. That means that we're reading the query store, we're capturing query store workload, and we're sending it back to the primary. We're capturing it, sending it back to the primary. So it's still read-only, but it's capturing the secondary workload. So if we go over to the primary. This is a query that, say, we ran for some CE feedback demo last year or whatever, that generates some cardinality estimation feedback. And we're just going to run that on the primary. And then we're going to actually run it on the secondary as well. Now, keep in mind, throughout this demo, there is a delay. I could speed things up if I had chosen to by flushing to the query store. You can flush your stuff to the query store. I chose not to because I wanted to show some quirks. But here I've done a query where I'm actually looking at the data based on replica type. So we ran the query on the secondary, but it hasn't been propagated back to the primary yet. It just takes some delay. And then we can execute the same query on the secondary, and we can do the same query, like give me the stats information. Now this is important. These negative numbers, they're not a bug. Those mean that this is in-memory information. It has not been persisted yet. So the mechanism works by generating some stuff that you'll see. Then those values they'll disappear while the information is being shipped to the primary. And then when it comes back from the primary, it'll be non-negative numbers, and they'll make sense. So here, that's happened with some of this information. The plan ID has been persisted on the primary. This one runtime stats ID that says -7, that's just in memory, but it will eventually get shipped off and then come back and show up as a non-negative number. So it'll be thrown if numbers are there and they're negative, and then they disappear, and then they come back. That's just how the system works. It's just the round trip time that it takes. So we're going to go back to the primary. We're going to find our query. We need to find our query ID to add the hint. So we select we find things based on our query text. We find it's query ID 5, query text ID 5. We find the query. Look at that. Query text ID 5 has query ID 5. That's convenient. And then we're going to actually set the hint. And this is the hint that we learned from CE feedback when we ran this before. And we're going to hint on replica group ID 1. That's hinting on the primary. So now we've set a query store hint on the primary replica like you would expect. And you can query it, and you can see, so in query store hints, you would see it show up. And there you go. There's our hint. There's our replica group ID. And there's our query ID. Cool. So I'm going to go ahead, and I'm going to actually add the hint for the secondary replica group ID 2. But I'm not going to execute the query yet. So the hint won't take effect until we execute the query. But you can see, if we zoom in again here, we've done the same thing. Now we've hinted query ID 5 on both replicas, same hint. So right now, the way to do this is to hint on both. If you don't provide that replica group ID information, you'll actually just default to the primary replica. Now we're going to go ahead and execute that query again that we just hinted and look to see if we got a different plan, right? CE feedback should change the plan. And here we have query ID 5 for both, and we've got 2 different plan IDs. We've got plan ID 5 and plan ID 10. So that's pretty interesting. So I'm just going to go ahead and I'm going to query again. What did we get? And here you can see that our information, our secondary information has by now been propagated onto the primary. And you can see that, we ran the query twice. We got 2 different plans for query ID 5, but we didn't run it on the secondary replica with the hint yet. So we can do that. I have to go in and do a little bit of query surgery here to just first look at what's running on our secondary replica. And so we've run it once with plan ID 5, that was without the hint. And we ran it again after we added the hint, and it's a different ID. The negative numbers are there just because it hasn't been flushed or persisted back on the primary and then shipped back. But we can actually, we know that it's going to get plan ID 10. So now, see, we only see plan ID 5, so those negative numbers disappeared. That's because it's being shipped back. So it sort of is negative, then it disappears because it's shipped to the primary, and then it reappears when the primary ships it back. So I'm going to go ahead and just look for plan ID 5 and 10. We'll just focus in on those 2 because that's what we're expecting, is that this hint would affect the query the same way. Then I get, sorry, I get a little impatient here. But I could have flushed. But just to give you a sense of the amount of time that it takes for that round trip. And here you can see I have actually executed the query with twice, once with the hint, once without the hint, and the hint has impacted the plan. We've got a different plan on the secondary replica. So that's pretty cool. So now Sharon can actually take learnings from CE feedback, apply them to query store hints on her secondary replicas, which is pretty neat.
Is this before the feature, or is this something I can do now? This is the feature, right, that's going to be in the future?
Yes. So query store hints is there now. The query store and secondary replicas part is not yet released.
So I can't put the hint that I can't put a hint on my replica right now.
You cannot hint on your replica right now. This is the future. Glimpse into the future.
I was hoping it would do it all for me, that I don't have to go and do this.
We want that too, and this is a good question, like where you just add the hint and it would apply to all replicas. Is that what you mean? Yeah. That's absolutely something that is work in progress. But yeah, that sort of instead of defaulting only to the primary, default to apply it everywhere. Yeah. I'm amazed sometimes. I like come up with this grand vision and then it takes a while to materialize, but we'll get there. All right, why am I? It doesn't like it when I click. All right, arrow. Okay, so now, oh yeah, go ahead. Question. So right now you can. Oh yeah. So the question is, can you add a different hint for different replicas? So right now the hints apply to a role type. So you can hint on all secondaries one way, and all primaries another way, and all geosecondaries a third way. But it's by that role. So if you have multiple secondaries and they're just secondaries, you can't have different hints for different ones for the same query. Yeah. Okay. Any other questions about that? All right. So now Derek is going to talk a little bit about some more feedback features.
So actually a non-feedback feature, and I'll bring back an old feedback feature, automatic plan correction, and yeah, I'll just call it out automatic plan correction. So coming back to Hugh, QG query. He likes writing big queries. He's the type of person that really doesn't believe in data lakes, data marks, data ponds, ETL, none of that stuff. He likes running all of his analytics on his operational database. He does have problems sometimes when he patches his servers, or he fails them over. He runs into this concept he's heard of, this thing called a compile storm. Has anyone heard that term before? Compilation storm? Yes. Wow. My favorite person, the only one person in the room that admits that. So,
You should define it.
yeah. So for Hugh, when he went and talked to ChatGPT or SQL Copilot, he asked, "What is a compile storm?" And ChatGPT came back and said, "Well, this is something that can occur when you have a failover, and say you had a bunch of queries running, store procs, ad hoc queries. Well, you fail over, all that stuff has to recompile. And recompilation can be resource intensive, right? So if you have a lot of procs, they look similar, the batch text is similar, maybe the parameters are different. And so you have 100 of those things that are running before you fail over, or your app might submit those hundreds when you fail over, when things come back up. Those 100 procs have to recompile. They might all try to recompile at the same time. Ad hoc queries that have a similar batch would do the same thing. Because compilation process is CPU and memory intensive, you run into a compile storm. It doesn't happen to everyone, but it is a real phenomenon, right? So to help with the effects of compile storms, now that I know the sound is on, I will turn it off. He was going to take a look at, well, we don't want to get started there. Yeah, I'm talking. Well, I should just let my demo talk for me. Essentially, what we're talking about here is there's a feature that was added to in SQL Server 2022 known as optimized plan forcing. And I just paused the video for right now. So really briefly, Hugh read about this feature in 2022. He wanted to understand what could he do to enable this? How can this help him with his compile storm problem? So if play would actually play again. Not start over. Okay, so start the Visual Work Database. I just set a couple of options. I do set DB Compat to 160. Optimized plan forcing does not need DB Compat 160. I set it here in this example because I believe everyone should go to DB Compat 160 so you get all of the other greatness that we've added. I flushed the plan cache and my query store. There is Hugh's query. I added set statistics time on just to capture some more stats about the query execution. We're going to save that off so we can see the parse and compile time as well as the runtime. And then what we'll do is in the second window, I'll just look at query store. It's a fairly long query, but this shows me Hugh's query, shows me how much time we spent in compilation, how much time we spent in the bind phase during compilation, which we'll talk briefly about in a few minutes. And we can see that very last number, 675 milliseconds, just in optimization alone, which is almost the entire time. It's almost more than the execution time. That's not good. So there is a column that's been added where we have this thing called a compilation replay script. And what we're doing is we're saving compile steps, if you will, and I'll go into a few more details in a few minutes. We're taking that data and we're saving it in the show plan. So the next time we need to do we run this query, and instead of going through the whole compilation process, we can read those steps that we've recorded and kind of shorten that time. So to do that, you need to force a plan, thus optimize plan forcing. So in my query here, I grab the query ID and the plan ID. I'm going to force it in this demo using the SP query store force plan. You can do this in the UI. I'm passing in my query ID, plan ID, and as Kate alluded to, there's an optional parameter, a replica group ID. Currently, optimized plan forcing cannot be forced on a secondary because secondary doesn't exist yet. So I'm forcing my plan. I will go back to my other window as soon as we catch up. And you can see, looking in query store, I have a compilation replay script, and this plan is now forced. So to make things a little more interesting for this demo, I'm going to clear the procedure cache. So I start with a cold cache. We'll just do a comparison of the two runs here of the same exact query. Grab the stats time output so we can compare that, and we'll also compare the query store results. And as you can see, as soon as I paste, the data looks a little bit better, right? So the time we spent doing compiling and parsing from a CPU perspective is a lot less because, again, we're reading the steps that we've compiled before, right? We don't have to go through that process again. We even saved a little bit of time, so the lapse time, the overall lapse time is actually going down as well. So if I put my two windows side by side, basically run the same query store query that I ran in the second window, just to show you the differences. You can see the compile time is almost in half. The actual time we spent just binding the plan is almost half. And the time we spent doing optimization all up is close to half. So in order to use this feature with SQL Server 2022, the main thing you have to do is force a plan, right? So Hugh says that's great. There's a couple ways I can go about doing this. I can query my query store and look to see where I have compile, replace, captured. That's a little intense. Maybe I want to use, I don't know, automatic plan correction to force plans for me. Well, in SQL Server, not Azure SQL, the force last good plan option, automatic plan correction, is not on by default. We do provide recommendations, but we don't automatically force plans. So what we did with folks that do apply cumulative updates, which I hope all of you do, In CU4 of SQL Server 2022, we introduced a new regression detection model, one that we introduced in Azure about a year and a half ago. We brought that to SQL Server 2022 in CU4. However, because we don't typically introduce new behavior changes or new features in CUs, except for query store and secondaries, we protected these behind trace flags. So there are 2 trace flags that come with the improvement. Technically, you only need one. That first one, 126.18, that gets you the new detection model, which is just, it's awesome. The second trace flag, 126.56, adds what we call it's an additional check, right? So we will check for plan regressions 5 minutes after we detect a plan change. And where that's significant is if you have, say you have, a query that runs, 500 times, right? Say 5, 10 of those times, those queries run with a really bad parameter, right? And causes things, you get parameter sniff, things go slower. After 5 minutes, maybe those queries time out, right? In the old model, APC would miss that, right? We would just see the queries that executed fast, everything's good. Those slow queries, don't worry about them. Now that we do a check after a plan change, after 5 minutes, which is a typical timeout period, we can catch those plans that got parameter sniffed and make things better, actually fix things for you. So the last part of this demo is really showing the state of automatic tuning for SQL Server, where it's off. Hugh decided he didn't want to actually turn it on. He wanted just to see the recommendations. So Hugh created a quick store procedure. He'll run his store procedure with a good parameter that runs fast. I'm just going to execute it 20 times so you can see how fast the windows scroll. We'll execute the store procedure again with a suboptimal parameter, so we get parameter sniffed. And now you can see with the good parameter, things are slow. So we got parameter sniffed. I think folks in this room have experienced that problem before. With automatic plan correction, even though it's not on, we can query the sysdm DB tuning recommendations DMV and see the recommendations. The actual good data is in JSON format, which is why you see me doing the OpenJSON. There are easier ways now coming to parse JSON, but I can see we did detect a regression. We said the query ran it started at 56 milliseconds and went to 202 milliseconds. That's a problem. I will also give you the script to apply the force plan yourself. So you get that for free. You can turn the feature on, and it will apply that for you, or you can just query that DMV just to see if the feature has caught anything. Questions?
So I turned on that 2D model. What I don't quite get a grasp of is how long it says verify if I look in the force good plans, DMV.
Mm-hmm.
And then in my case, it usually doesn't persist very long. So how does it do that verifying step? What is it doing?
So with the old model, verification is looking for more executions of that query, right? So if that query regressed and we don't see it again for a period of time, we say, oh, there must not be a problem, and we just don't do anything. With the new model, we don't need as many samples of the query, so if we see it 1 or 2 more times, we'll say, oh, this query really has regressed, and we'll persist that forced action.
And when you say the new model, do you mean including those trace flags?
Correct. The first one for SQL Server 2022.
Yep.
CU4. We're later. Yes.
The automatic plan regressions enterprise only, is the grab-in, the recommendation available with the enterprise edition?
Unfortunately, no. That is an enterprise feature. We've definitely gotten the feedback about trying to take some of these features and also make them available in standard edition. I can't promise that you'll see that in the next version of SQL Server, but we hear that a lot, right? So things like this would be very helpful for standard. I don't think there's anything enterprisey about catching regressions, right? You have a bad query, it's going to run bad in standard or enterprise. Doesn't really.
So let's say today my data looks good for this particular query plan. And months later I have another set of data change. It's still going to be forced that this plan because it's set auto-tune or new query plan pop up that it will going to automatically choose that new query plan.
So if you have a new query plan,
Running better than this, let's put like that.
yeah. So if things change with that query, if the same query comes through and it starts running better, APC will no longer use that force plan, right? You won't use that plan. You'll actually see there are cases where we will remove the forced bit on that particular plan, if it's still in your query store.
But what if it stay with, I set up auto tune. I have seen it in Azure where I have to be responsible for this plan. This one, or I have to be done auto tune.
No, in cases where you've seen auto-tune not unforce the plan for you, that shouldn't happen. Has that happened recently to you, or?
No, I'm talking about, let's say, not in recent months.
Okay, so if it's still happening, it's like I said with the new model, we try to avoid that situation because there were times in APRC, I keep saying APC, where we would miss where a good plan would come in, but we would insist, no, we're going to keep this forced plan, even though the plan changed. We do a much better job now in Azure DB. You don't have to turn the trace flag on in Azure.
I did in the past, just wanted to ask you.
Yeah. Yes, sir.
You said there was a threshold of queries taking more than 3 minutes, 5 minutes. Is that a parameter that you can implement yourself? If you
Correct.
have queries that need to take like half an hour, I still want it to optimize the queries for it.
So currently, the threshold is not configurable. The 5 minutes was chosen based on what we were seeing in Azure, right? So in the 95th percentile of bad plans that were timed out within 5 minutes. So that's the number that we chose. But if you find that there's a problem in Azure, you can open a support case, and our support folks can actually change that number. You don't have direct access to do it, but we can do that on the back end. On SQL Server, you have no way of changing that threshold today, right? I'll take the feedback. It might be something we can add in the future. Since we added this in the CU, we might be able to make that change. No promises, but. All right, so now that Hugh's learned about the optimized plan forcing, he wants to know when would optimized plan forcing actually engage. So this chart is really meant to just kind of give a visual of 3 different queries that are running. We can see in the first chart where compile time was really low, execution time was great, overall time was great, right? So automatic plan forcing wouldn't care about that.
Is there a legend on that? The orange is the execution time.
Oh, it's very
The
small.
blue is the compile time.
Yes.
And the gray is the total time.
Correct, thank you, because it is small. So on the third plan, you can see the compile time is very high, execution time is pretty low. This would be interesting to optimize plan forcing. Now I will say, if you run very, very simple queries, optimized plan forcing just won't even bother, right? So if you do like select one, there's no point in saving that. It doesn't make sense. If you have queries with multiple table joins, that kicks in our heuristics to say this might be more interesting to capture that compilation replace script. And I say it's more interesting because it does cost us to capture those optimization steps. So we don't want to do it for every query, right? It's worth it when we capture them, but we don't want to do it everywhere. Like I just mentioned, optimization replay or compilation replay really records what we call transformation rules and implementation rules, which I'll spend maybe 20, 30 seconds talking about. It captures those important steps, saves them in a compressed format in the show plan XML. It is in a hidden attribute, so if you just crack it open, you won't see it, and that's on purpose, because we don't want people going in there saying, oh, here's the rule, I'll just make up a rule and stick it in there myself, and now you have an invalid plan. But it is in there, and I say that because nothing's free, right? So it does take up a little bit more space in show plan, which gets saved to your query store. So I won't say it's adds like 10 meg or 20 meg or a gig, but it does add some extra space.
So does that mean that the execution plan never stays in the cache?
No, it stays in the cache.
First one.
The force one could stay in the cache or it may get kicked out, but it wouldn't matter. So if you force it, we'll always use, if it's in the cache, we'll just use that, right? If you force the plan, we'll look at the show plan that's in Query Store. We do an abbreviated version of compilation based on what that show plan, and then we execute it when you force a plan. That's kind of how it works.
So it's like a brand new query that checks if the cache has this plan, and if it's a force plan, so it checks if the force plan is in it, right?
Correct. Yeah, it would check the cache first always, right? If it's not there, then we read that show plan, we do a small bit of compilation, and then we use that plan.
So, are you saying, okay, and maybe I didn't hear what he was saying, so maybe it's the same thing.
I should have repeated
You
it,
should have
sorry.
But are you saying that, okay, if you force a plan and it's in the cache, it's just going to use that plan, it's not going to recompile at all?
Correct.
But if you force a plan and it's not in cache, it's going to do this replay thing.
With this feature, right? So,
Okay, I'm confused about the relationship between the two features, if they're separate.
yeah,
Forcing a plan versus replay.
yes, they're two separate. So prior to this feature being introduced in SQL Server 2022, you could force a plan, right? So if you forced a plan, we essentially took the show plan XML, and we would read that from the query store. We would only do that if that plan wasn't already in the cache, right? So if the plan's not in cache, instead of recompiling what you forced, we read the show plan XML, and we do an abbreviated step of compilation, and then that plan goes back in the cache. Does that make sense? Kind of.
And then you turn on replay separately?
Yes. Well, so we're going to give you a deal. So you upgrade to SQL Server 2022, you will get this option for free. We turn it on by default.
It's on by default.
Yes. Now you can turn it off. There is a DB scope config option to turn that off, but you get that.
Then it by default disable it because you usually make it on.
No, you can. It comes on with when you install SQL Server 2022. Your database will get this.
Well, new databases, right? If you restore, no, every database?
Everything. It's not tied to Compat.
Okay.
So it's an engine feature that we added. So you just get it.
No.
Doesn't matter about Compat level. Now, we won't actually force the plan for you, which is why I showed the demo where you can use APRC or ABC to force it. Or you can go through the query store and look, just mine it, right? And say, are there any queries here that have the compilation replay script? If they do, they may be good candidates for me to just force. Does that make sense? So you can do it yourself, or you can let APC turn it off for you.
Okay.
No questions? All right.
Was it? Okay.
So quick thing. I'll go through this
Yeah.
super fast. So I did talk about the rules that we save in the show plan XML. I won't go into too much detail due to time, but we have a transformation process as part of optimization. And you can think of transformation as we're trying to compare this thing to the next thing, right? So this can be a table. So we're trying to compare table A to table B. And the whole point of transformation is to say things are equivalent, right? So I can join A to B, or I can join B to A, and it's the same, right? Or if you do multiplication, it's like A times B gives you the same answer as B times A. Transformation is really about rearranging things in what we consider the most optimal way to get the same result. There are 3 pieces to the optimization process, full optimization. I won't go into the sub-steps or of trivial plans and things of that nature. So we go through something called simplification. So again, simplification is about simplifying what a query is doing. So if you have, let's say you have a filter in your query, and you have your query is joining 12 tables. Let's say you have 1 million rows in all those tables. Instead of taking that filter and calculating all 12 table joins of 1 million rows and then applying the filter, just to maybe say we're only going to get the result of 1 row and throw away all that other data, that's just a lot of wasted work. So with simplification, we'll say, oh, there's a filter in this query on this one table. We need to push this filter all the way down those joins to the actual table that has the filter, and then we'll just get that data. And we save a lot of work. That's what simplification is doing. Exploration is really about exploring different ways to build a relational tree so that we can figure out how to structure the best plan in a logical fashion. One quick example that I use for this is, think of it as, I'll use Hugh. When Hugh was in school, his teacher gave him a long multiplication problem, right? His teacher said, multiply 73,000 by 42. So Hugh could go to the board and write 42 and then the 73,000 on the bottom. He could do that, or he can reverse it and put the large number on top, smaller number on the bottom. If he does the former, he has to multiply, do 5 steps of multiplication. It will still get him the right answer, but it's a little bit easier if he had the larger number at the top, smaller number at the bottom. He does a couple steps of multiplication, some addition, and he gets the answer. Exploration is doing that with the query tree, right? We're trying to rearrange things, figure out what's the most cost-effective way or the cheapest way to get the same answer. So it's just rearranging things. And it's using stats, histograms to figure out weights or costs, right? So costing in SQL Server speak is really, it's a unitless number, right? I won't say it's meaningless. It's basically, to make it super simple, oversimplification. Bigger numbers are bad, smaller numbers are good, right? So we weight things. We say this operator costs 500. This next operator costs 5. We'll take the cheaper 5 operator. Then we get to implementation. Implementation is really all about taking those costs and converting logical constructs into physical constructs. And what I mean by that is when I talked about comparing A joined to B, we now need to figure out how do you want to join A and B. Based on the cost, do we want to do a nested loop join? Do we want to do a hash join? Do we want to do a merge join? And that's all based on cost. And that's happening in implementation. Same thing goes with indexes. So if you have multiple indexes, at that phase, we try to figure out which index do we want to use, which would be cheaper. Oh, if I don't have an index here, I'm going to throw up a missing index hint, because if this index was here, it would be useful. We're doing those things. Those types of steps are the types of things that we save in the compilation replay in the show plan XML. So we shortcut a lot of those things that I just described. I need some water. I apologize. Okay. Sorry, Kate.
All right, yeah, good. Is it my turn now?
It is your turn.
All right.
Take it home.
And so I'm going to be mindful of time here. I'm going to kind of blow through this section. It's not a very long section, but we're going to finish on time. We've talked about all these different features, and a lot of them have knobs, and they have multiple knobs at different levels. So I'm going to go through this real fast, but the idea being, where do you look if you want a feature to kick in and it's not kicking in? You're like, why am I not seeing this, right? So one of the places you can start If you're running on Box, right, this isn't available in Azure, but this server config, right? If your maximum degree of parallelism at the server level is set to 1, you're not getting any parallelism, you won't see degree of parallelism feedback, for example, right? And if you can, if you're running on Box, you can change it using these options here. Similarly, there's trace flags. There are actually trace flags that are on in Azure, even though you can't change them, and they can be on at the server level, right? So you can turn on trace flags that will toggle the availability of a feature. There's a lot of them. Again, in Azure, you can't specifically set them, but there's a lot of them, and in deference to time, I'm just going to blow past that. But you can turn them on, turn them off, et cetera. Yeah, you can even, this is where you can check in the server properties if you're on-prem. And then there's the database config, right? General settings. So here you're looking at compatibility level, is my query store on, that kind of thing. These features that rely on compatibility level or rely on the query store, if those things aren't turned on or aren't set correctly, you aren't going to get the feature, right? So again, these are things you can you can change. This is how you could turn on query store and set a custom capture policy. You can also just check what's on, what's not on, right? And these options here are the same as the options Derek was just talking about with APC. And then there's also database scope config. So all of these features have database scoped configurations. It's all documented, and there's a bunch listed here, right? But memory grant feedback has a couple of them. CE feedback has one. DOP feedback has one. Parameter sensitive plan optimization has one. All these, new intelligent query processing features actually have database scope configurations, and you can change those, and you can change them anywhere. If you're on Azure, you can turn it on and off, et cetera. That's all something you can do. So that's how you can check, and then you can change it by just setting them on, off, or changing the max degree of parallelism if you wanted. Similarly, you can have query hints. Now, I mentioned that a lot of these features aren't super compatible in the presence of hints. We say, you hinted it, you know what you're doing, we're not going to touch it. We know that we need to revisit that assumption, but for now, this is some things you can do to see if the feature is not kicking in. Similarly, you can add hints in Query Store to see what hints are already in use, and you could possibly add hints if you wanted here. So yes, and that's how you can change it. Similarly, a lot of things, some features, adaptive join is one, that you have to actually look at the execution plan. You can't see it in a DMV, you can't see it in Query Store. If adaptive join kicked in, the actual execution plan is the only way to see it. We also have a lot of X events. A lot of them are in the debug channel, and you wouldn't want to run X event sessions all the time. They could impact performance. But if you're curious about a feature, what it's doing for a particular query or subsection of your workload, you could turn on an X event session, see what's happening, and then you could decide if it's doing what you want or not. So here we are. We're, Sharon and Hugh, they've upgraded their database from 1.16 to 2022. They've turned on Compat 160. They're seeing these feedback features kick in. They're leveraging Query Store. They've got optimized plan forcing working. They've got automatic plan correction going on. They go to their happy hour at the end of their third day of pass, and they're super happy. They're excited about what's going on. They're thrilled. And into the room walks their friend, Fabric, who hasn't thought about his database at all. He just went to the latest and greatest of everything, right? He said, give me all the latest stuff. I want to just be cutting edge, whatever. And he's like, I haven't heard of any of these features. And they start, digging into his settings, doing all those troubleshooting steps. And it turns out he's getting all of this stuff is just on by default. And he's benefiting, his workload is benefiting from all this. And so they're all happy, which we hope you are. So that's, yeah, question?
How we can figure out if the automatically tuned plan better or worse?
In Query Store, right?
So
You would look at the query, if the plan is different.
I need just to look through all query stores and try to find if it's before it's better or not.
So in Query Store, there's actually a way you can find a query by text. I showed that in my demo. And then you can find the query ID. And you can see if there's different plans for that query ID. There's also visualizations that you can track a specific query and see the different plans and see the performance. That's all in Query Store. And then anyway, this is the list of all the other sessions that we're doing at PASS this year for Microsoft, and some links. And with that, we can take questions. Though I respect that we're at time, so thank you. Yeah? Automatic plane correction? Once automatic plane correction is on, do you still need to force plans on top of that?
Only if you want to.
Yeah, only if you see something that it either didn't pick up or you want to really fine tune it. You still can, right? It will respect force plans.
Yes.
It will just only look at and investigate the ones that qualify for its criteria. So if you have other things that you know, you can always force them. Once you force a plan, will automatic plan correction override that force?
Typically, no.
No.
There are edge cases where it could happen, but in most cases, no.
Yeah. Yeah.
I think personally I don't like things, but if I keep applying things on my SQL and shift studies by story, is going to be accurate every time, or we need to be evaluating the thing extra time?
I'm sorry, could you, if you apply a hint in your query store,
Do I have to evaluate that thing by trying?
it will it use the hint every time? Yes, every time it sees that query, it will use that hint, yeah.
So is there a way we can evaluate the this hint is correct compared to the 6 months result?
So you could remove hints, but we don't have a mechanism right now to like time box, say, apply this hint for 24 hours. We don't have anything like that right now. Yeah. Yes, Peter?
In the documentation for the X events specific to IQP documented so they can go play with them.
Are the X events specific to IQP documented?
They're not called out as
IQP.
X events, but each feature has documentation for its X events.
Yes.
90%.
Yeah.
There's
Yeah.
some that we didn't document, but you can figure them out
Yeah.
by name. Yeah.
And if I can't figure them out,
You can email.
You
Kate.
know where to find us. IntelligentQP@Microsoft.com.
Yes. Yeah, but most of the X event names are, especially ones in the debug channel, they're explicit enough. The name,
Pretty
it's
clear.
easy to figure out.
Yeah.
We're not using any query hints for the query store, but all of a sudden we start getting the errors.
What? Okay.
The error, the incorrect syntax near bracket.
Haha. Talk about that.
Oh, the empty hint? That's the CE feedback bug.
Yeah.
Yeah. Yes. So what has happened is CE feedback has run, it generated a hint that it thought worked, and then what happens? It like decides it doesn't work anymore
it doesn't-
and it removes it?
Yeah, it tries to remove the hint that it thought it wanted.
And you end up
and
with
it
sort of
with
this
a
empty hint.
parenthesis. An empty hint is what.
But we're not using it.
No.
CE
it's
feedback
CE
does
feedback
it. CE
is
feedback
doing
adds hints automatically.
Okay, so when you guys gonna?
We're working on the fix.
Well, I think, we're
We're working on the fix.
Yes.
We know about the problem.
Yeah, I think we actually have the fix checked in. We just have to get it in CU. Yeah,
Yeah. Okay. Awesome.
yeah,
So
yeah.
it's not that severe, it's the next step, maybe.
Yeah, yeah.
Maybe. Yes. But yeah, we knew about that problem. It's
Yeah,
not.
we know about it. We fixed it. Yeah. Cool. Awesome. Thank you.